Okay, the last topic we're going to dive into deals with percentiles, but some specific percentiles, not just percentiles in general. So you have seen this data before. It's the last time you're going to see that data. I need you to enter it into your calculator, okay, one last time. And then when you're done, I want you to run one variable statistics, okay? So pause the video and do that. And then welcome back. All right. You need to find a few things on your calculator, and you're going to need to scroll down. Now, you've already found the median before. If you scroll down or use your arrow keys, okay, you will see the median there, but you'll also see a Q1 and a Q3. Those are the values that we are going to be pulling out. Okay, so find the quartiles. Again, you're going to use that one variable statistics command. We've used it a lot. The lower quartile, or that Q1, you should see as 1, and that would be 1 gram of sugar. Okay, the median should be 3 grams of sugar. And then Q3, which is known as the upper quartile, is 10 grams of sugar. Okay, now it may not come as a surprise to you, or maybe it will, I don't know, but these quartiles correspond to specific percentiles. Okay, so quarter, in your head, you should be thinking maybe in terms of 25, right? There's 4 quarters in a dollar. So the lower quartile, this is also the 25th percentile. The median, since it's smack dab in the middle, is the 50th percentile. And the upper quartile is going to be the 75th percentile. Okay, so the 25th and the 50th and the 75th have special names. The lower quartile, the median, and the upper quartile. Lower quartile and upper quartile symbolized with Q1 and Q3. Sometimes the median, by the way, can be seen as Q2. All right, not very often, but you will occasionally see that. So I'll just briefly mention it in case that ever comes up. All right, find and interpret the interquartile range. Okay, interquartile range. So inter meaning between, and quartiles referring obviously to the quartiles. So the interquartile range, which we're going to abbreviate IQR, is going to be the upper quartile, Q3, minus the lower quartile, Q1. Okay, so for us, that would be 10 minus 1 is 9 grams of sugar, using the data from up above. And it does say and interpret, okay, and interpret. So I want you to think about, if you've got those data points all lined up, okay, data points all lined up, and we've got the 25th percentile, and we've got the 75th percentile, and here's the 50th, and here's the bottom value, and here's the top value, okay? What I want you to consider is what percent of the data falls between the 25th and the 75th percentile, okay? That literally means the middle 50%. So that comes into our interpretation. The middle 50% of menu items have a range of 9 grams of sugar. Okay, so the interquartile range is talking about the middle 50%. Always, okay? Always, always, always. There's never any other value it's talking about. All right, find the fences. Find the fences. Okay, so the fences are another way to determine outliers. We've already talked about 2 standard deviations above and below the mean. Okay, that still works, all right? But this one is by using fences. So let me tell you how to find the fences. Okay, so fences, we've got a lower fence and we've got an upper fence. The lower fence is found by taking the first quartile, Q1, and subtracting 1.5 times the interquartile range. And the upper fence is found by taking the upper quartile and adding 1.5 times the inner quartile range. Okay, so let's do that real quick. Our first quartile is 1, so 1 minus 1.5 times 9, our inner quartile range, is negative 12.5. And our upper quartile is 10 plus 1.5 times 9, and we get 23.5. Okay, those fences are the boundaries for outliers. So this is like method number 2. We'll get yet another one. We've got the 2 standard deviations, and now we have this one. But let's do the interpret part. Interpret the fences, okay? Interpret the fences. So what this means is that if the others are outliers, okay, if anything outside of negative 12.5 and 23.5, outside of that is an outlier, that means all the values in between are the typical ones, the ones we expect. Okay, so we expect the items on the menu to have negative 12.5, again, which is silly, up to 23.5 grams of sugar. Okay, that's the expectation. That would be the common values. So again, assuming that fences are a second way to determine outliers, and notice here, we don't have the standard deviation. We could have found it if we, use our one variable stats, but sometimes you don't have it. Sometimes all you have are these percentiles, and so the fences let you find those outliers. So do we have any outliers? If you go back up and look at the data itself at the top of the page, are there any values? Obviously no negative ones, but anything above 23.5, and you will find that yes, there are. 27 grams of sugar is going to be an outlier. Okay. All right, we're getting to the end here. Find the 5-number summary. Oops, sorry, I meant to turn on the highlighter. Find the 5-number summary. So when you see those instructions, the 5-number summary means these 5 specific values. It means find the minimum value, find the first quartile, find the median, find the upper quartile, and find the highest value or the maximum value. That's it. Okay, and we've already found 3 of those, and in fact, if you look at your calculator again under one variable statistics, the minimum and the maximum are also there as well. So when you do have an extra large data set and it's not easy to find the maximum or the minimum, it tells you. So the 5-number summary gets spit out of your calculator. In this case, the minimum is 0, the first quartile again is 1, median 3, upper quartile 10, and our maximum value was 27. Okay, now what can we do with that? We can make a box plot, and this is hopefully something you've seen before. I'm going to make like a real generic box plot for you to begin so that you kind of know how it works. Okay, so in a box plot, you end up with a rectangle. Sorry about the little wavy lines here. Okay, you end up with a rectangle and a vertical line somewhere on the interior of said rectangle. It doesn't have to be directly in the middle. I'm going to put mine there. You can put yours anywhere you want. Okay, then there are some tails that come out. And again, however long you want to make them is fine with me. And then occasionally you'll have some extra dots out on either end. They can be on one end, both ends, or the other out past those little tails. Okay, so let me tell you what happens. Okay, this value on the far left, this is the minimum value that is inside the fence. Okay, the minimum value, but it's a data value. It's not the fence. Okay, it's a data value that's still inside the fence. So in our example, had we had any data values below negative 12.5, those would have been little dots to the left. Okay, the edge of the left edge of the rectangle, that's your first quartile. Okay, the line in the interior of the box is your median. The line on the right edge of your box is your upper quartile. The end of this next tail is your maximum value, again, that's inside the upper fence. And if you happen to have any values outside of the fences, then those are the outliers, and they are plotted as separate little dots. Sometimes you'll see them as asterisks, okay? Now, along the bottom, you'll always have a scale, okay, a separate scale. But for right now, what I'm going to do, I'm going to leave out the scale because I don't have any particular data in here. I'm just going to show you again, like what's what. So notice what's happening here is this is 25% of the data. There's 25% in here, 25% here, and another 25% here. Okay, it's not about, oh, that region, that box on the right side, oh, that's really big, there must be a lot of points in there. No, same amount of points, 25%. It just means those points are more spread out. The data values are more spread out. And then notice that right here, here to here, this is your inner quartile range, which is that middle 50%. Okay, and so the closer or the smaller one of those little regions is, that means the more data values that are very close together you have packed in there. So let's take the data in our particular example and let's go ahead and make our box plot. So we go from 0 grams of sugar up to 27. So I'm going to go ahead and put in a line, and I'm going to make 0 down here. And I'm going to count by fives. So 5, 10, 15, 20, 25, that'll be 30. Again, we want to go just a little past where we've got available. Okay. Our minimum value inside the fence of negative 12.5 is 0. So here's the edge of our plot. Our first quartile is at 1 gram of sugar, so the edge of our rectangle is at 1 gram, so like right there, okay? The rectangle goes all the way over to Q3, which is 10 grams of sugar, so I'm going to go ahead and put that one in. And then our median was 3 grams of sugar, so that's about right there, okay? Then our upper value inside the fence, so go back to the data at the top. Remember, we have a fence of 23.5, and we know we have an outlier at 27, okay? But the next smallest inside that fence is 22. So that's where we're going to come back here, and we're going to go out to 22, about right there. And then that outlier of 27 grams, that's going to get a little dot, okay? And we do still need a few things. We do need a title. Okay, so what is this about? This is about sugar content in the menu items. Okay, we've got a scale. That's important. Okay, so make sure you've got a title. Check. Make sure we've got a scale. Check. And then make sure you do some sort of label on that scale. So what are those about? Okay, and this is about grams of sugar. And so a little label there to tell us what's what. Okay, and again, 25% falls on that tail on the left, 25% falls in that first part of the box. So that means a lot. I mean, 50% of the menu items, think about that, 50% of the menu items have between 0 and 3 grams of sugar. All right, then the other 50% have 3 up to 27 grams of sugar. So overall, again, I would say this is a pretty healthy menu that we're looking at.